Welcome. We want to see how classification can be done. Earlier, we have seen use of ChatGPT in linear regression. Now, this time we are seeing an example of classification model. Of course, this time we will go through the exploratory part a little bit quickly because EDA part we have already done in earlier lectures. But what is classification? So that I will explain when after 2-3 cells are executed. Now here, first cell is our usual. We are importing some basic libraries. So import libraries. This star mark indicates it was executing. Now it has executed. Now there are two sets, train and test set. So this time we don't need to split our original data set into train and test part. They have already given us train and test set separately. So sometimes we receive data in this manner also. So that is fine. So I have imported train dataset and test dataset. This is the source from which I have taken the data. Okay. And this is the discussion about data. So this discussion is important because you have to understand what each column means. So let us see what are the columns and what do they mean. In train dataset, these are the columns, and in test dataset, there will be one less column, but everything else will be same. Now, loan ID. Loan ID is just a unique ID. So that means if there are 10,000 observations, then for each observation, there will be different loan ID. Okay. Then gender. Gender of the applicant who has applied for the loan. There can be only two categories, male and female. Okay. Then married. That is whether the applicant is married or not married. Again, there are only two categories. And we will see that by quick exploratory data analysis that how to know this. Then dependents. How many dependents are there? Again, there are only four categories. Either no dependents or one, two, or three or more. We are clubbing them into one category. So that is how it is. Then applicant educational qualification. So graduate, undergraduate, postgraduate, what is the educational qualification? Then applicant employment status. Whether the employee, if the applicant is self-employed, then say yes, or if he is not self-employed, then so say no. Then applicant's monthly salary. For example, these are some example values. Co-applicant's monthly salary. These are all in US dollar, and this is according to this source from which data is taken. This is real data of some financial institution in US. Then loan repayment period in days is written, but I think it is in months. So 10 years means 120 months, 30 years, that 360 months, like that. Then record of previous credit history. There again, there are only two choices, 0 or 1. And the location of the property, three choices, rural, semi-urban or urban. Status of the loan, whether the loan will be granted based on rest of the features, yes or no. So now I can explain what is this classification. Say for one particular person who is approaching to the bank for applying for a loan, these are the features, gender and married and all that. He supplies all these details and then asks whether or not I am eligible for loan. So all the applicants, they make a set of a large pool of data points, and from them we want to divide those data points into two parts: eligible and not eligible. So there are only two classes. That is why this is called binary classification. Now let us take example. This is train DF. Let us take what are the column names. Column names are what we have already seen, but in the train data set, that loan status will be there because you have to first train a model in which loan status is also known, say on maybe 70% of the observations. Then in test data set, all the features will be given and you will be asked to predict the loan status. So that means based on this feature, some value of gender and married and salary and co-applicant salary and credit history and all others, you will predict, that is your model will predict whether or not the applicant is classified into yes segment of that large data pool or no segment of that large data pool. Okay, so that is why this is called binary classification. Let us have a quick view of our train data set and test data set. So these are top five and bottom five rows of train data set, and these are top five and bottom five rows of test data set. Now, if you see both, you can see this time there are non-variables. In regression, we had taken very simple data set. In fact, we use ChatGPT itself to create a data set. But in classification, now this is a actual data set. So there are non-variables, and therefore some treatment of that will be required. Similarly, in the test data set also somewhere there might be, yes, there is a non-variable here. Okay, so in this observation or in this ID, loan ID, so credit history either is available or not available, but one person has just left it blank. Similarly, this person has also left it blank. So then you have to do some treatment of that non-variable. Now, data exploration can be done by that pandas profiler that we have already seen earlier in one line of code only. But this time we have made one such function. What does this function do, accomplishes is that uh, this is the name of the function, table characteristics, and it takes the entire pandas data frame as an argument, and then it finds columns one by one. One column is how many zero values are there in entire data frame. Second column is how many missing values are there in entire data frame. And third column is what is the percentage of total values. So how many total zero values are there and how many missing values are there. How many percentage zero values are there and how many percentage missing values are there. That is what this function will find, and it will return. We store the result of the previous lines of code in this column characteristics. Okay, and then we return that column characteristics. So to call this function, we know that we have to use just the name of the function, and we provide it with the data frame. So first we call the function for the train df, and as I call this, oh sorry, did not execute this. Yes. Then first I should clear all outputs. That would be better. Yes. Now for train df, you can see that in train df, this column has 89 zero values, this many missing values, and the percentage of total of missing and zero values are 8.1%. Okay, this is percentage of total values for missing values, I think. And this is the percentage for 0 plus missing values. It also gives the data type that these columns credit history, uh, loan amount, loan amount term, these three are floating point or that is numbers, while rest self-employed or not, dependents, they are object that are usually strings. Okay. Same function we call table characteristics of test DF. So a table is given returned by the function and you can find how many zero values are there, what is the percentage of zero values, how many missing values are there, what is the percentage of missing values and all that. Now, this may not give clear idea to some people, then we can even visualize this. So this is how first you can create missing value heat map for train DF and missing value heat map for the test DF. You can see that loan ID does not have any missing value. That is expected because each observation has unique ID. Gender has some missing value here. Then this married column does not have any missing value in the train DF, but and no missing value in the test DF also. And similarly, this education has no missing value in either train or test DF. Applicant income also has no missing value. Co-applicant income also has no missing value. Then loan amount has some missing values. That is, some treatment is required because otherwise, without knowing loan amount, how can you predict whether or not that loan should be granted? Credit history has large number of missing values. And later on, we will see that credit history is the most important parameter which will decide whether or not loan should be granted. So this is how it is. Let us get summary statistics. So this summary statistic in regression we did not include this option. So if you do not include this include is equal to all, then it gives only summary statistic for uh, number type of columns, but here it will give summary statistic for all the columns, whether they are numerical columns or categorical columns. And you can see how many observations are there. This is for train DF. Similarly, this is for test DF. So train DF has this many observations, test DF has this many observations. So it is roughly around 70-30 division that they have only given to us in the data. Okay. Then in this mean etc none is there because loan ID is categorical variable or ordinal type of variable. Then here also gender is not number, married is also not number. So this standard deviation and minimum value and maximum value does not apply. But here you can see this applicant income. For that there are some minimum, maximum, mean, standard deviation, etc. Co-applicant income also. So wherever there are numeric values, there you can find this. Okay. Similarly, this is the summary statistic for the test data set. Summary statistic is useful to know one thing, as we have seen in that regression example, is that what are the ranges in which data varies. For example, here the minimum value is 152, maximum value is 81,000. That is in applicant income. While here the co-applicant income minimum value is 0 to maximum value is 41,667. Okay. Then loan amount minimum value is 9. And remember this loan amount is in $1,000. So 9 means $9,000 to maximum amount is 700. So $700,000 or that means 7 lakh dollar in our Indian number system. Then this is the loan amount term that has this minimum value. Uh, 12 it is in months to 480. 480 means 40 years, or that is 480 months. Okay, so there is a big variation again in minimum and maximum value. So one should consider min max scaling or normalization of these numerical columns. Okay, then display heat map. Heat map will show the correlation between the various variables, and then we can decide how many of the features we want to keep. And as you go towards red side, yellow, orange, and red side, the correlation is higher. As you go towards blue side, the correlation is lower. Now you can see that most of these are blues. Only one this is maximum correlation, that is between applicant income and loan amount. So that means that these two are highly correlated, but the correlation is not that strong also to keep it as or to decide that I want to remove this variable one. I will keep only one of the two variables. For that it should be around 0.90 or above, then I can remove one variable, so I will not remove. Okay, then we can plot this pair plot, but I will take from here in the next lecture. Thank you.